We are always on the hunt for faster, more solid wireless connections, right? But what if the next generation wasn't just a little bit faster, but a massive, game-changing leap forward? Well, that's exactly what we're digging into today. We're breaking down Wi-Fi 7, also known as IEEE 802.11b-E, and trust me, it's set to completely change what we expect from our networks. Now, all the deep technical info we're about to get into comes from an incredibly detailed report by the folks at RFI Detectives, who are part of Virtualization Options LLC. This is actually part 11 of a huge 20-part series they put together, so we're jumping straight into the really good stuff. And that really brings us to the big question, doesn't it? I mean, Wi-Fi 6 and 6E are already pretty amazing, so why on earth are we talking about a new standard that's promising speeds more than 4 times faster? What problem is this new generation actually trying to solve?
Okay, so here's our game plan. First, we'll nail down what Wi-Fi 7 really is. Then, we'll get into the 2 main pillars: how it unlocks that incredible speed, and, just as important, how it smartly handles tons of devices. After that, we'll take a quick peek into the future and then wrap it all up with the big takeaway.
So let's get right to it. What in the world is Wi-Fi 7? What was the driving force, the mandate that kicked off this super ambitious new standard? You know, this quote from the source material just says it all perfectly. The goal wasn't just to make the speed number bigger. It was about delivering 2 critical things at once. Yeah, extreme throughput, but also ultra-low deterministic latency. And that word, deterministic, that's the key. It means latency that is predictable, reliable, and consistent. For real-time apps, that's an absolute game changer. And hey, a quick but really important clarification for all of us in the tech space. The official name is 802.11b-E. Please do not get this confused with the old school 802.11b from way back in 1999. You remember that one, right? It maxed out at a blazing 11 megabits per second. We are talking about a completely different galaxy of performance here. So, what's pushing this need for deterministic performance? Well, think about high-res extended reality, AR and VR, where even a tiny bit of lag totally shatters the illusion. Or what about industrial automation, where robots need connections that are absolutely rock-solid and predictable? Then you throw in cloud gaming and the absolute explosion of IoT devices all screaming for bandwidth, and yeah, the need becomes crystal clear. And just to be clear, this isn't some far-off pipe dream. It is happening right now. We started seeing Wi-Fi 7 certified products ship early this year. The first part of the standard officially dropped in May 2024, and we're expecting the full thing to be ratified by the end of the year. Wi-Fi 7 is officially here. So how in the world does Wi-Fi 7 actually hit these unbelievable speeds? Let's cop the hood and look at the raw horsepower upgrades. It really boils down to 2 main ingredients that give it this extreme throughput. First up, we've got channel width. The easiest way to think about this is like a highway. Wi-Fi 6E gave us a pretty nice 160 MHz wide highway. Well, Wi-Fi 7 just doubles it to 320 MHz. We're not just adding a couple of lanes, we are building a data autobahn right next to the old highway. And this is only possible because it operates in that beautiful, clean 6 GHz band, away from all the legacy device traffic. Okay, so the second ingredient is all about packing the data in more tightly. It's a modulation scheme called 4096 QAM. So if the channel width is how wide the highway is, QAM is how much stuff you can cram into every truck driving on it. This new level packs 12 bits of data where Wi-Fi 6 could only pack 10. That's a straight-up 20% boost in efficiency. Now the catch is, you need a really strong, clean signal for this to work its magic. So you combine that massive data autobahn with trucks that are packed 20% more efficiently, and what do you get? You get this, a mind-blowing theoretical maximum data rate of 46 gigabits per second. It is just a monumental jump in raw, unfiltered capacity. But here's the thing. Raw speed is only half the story. Real-world networks are messy, they're crowded, they're chaotic. So the truly revolutionary part of Wi-Fi 7 is how it manages all that power. It's not just about being fast, it's about being incredibly smart. And the star of this show is a feature called Multi-Link Operation, or MLO. This is a huge deal. For the very first time, a single device, like your phone or laptop, can talk to an access point on multiple frequency bands, like 5 GHz and 6 GHz, at the exact same time. It can balance the load between them or instantly fail over if one band gets congested. This is the secret sauce for that ultra-reliable, low-latency connection we were talking about.
Wi-Fi 7 also gets a lot smarter in how it slices up the airtime. So, with Wi-Fi 6, you could give a device a single resource unit. Think of it as one lane on the highway. With Wi-Fi 7's multi-resource units, you can assign a device multiple smaller lanes as needed. It's way more flexible and means almost no bandwidth gets wasted. And check this out, another brilliant upgrade. Wi-Fi 7 doubles the number of spatial streams from 8 to 16. But wait, it's not about trying to cram 16 antennas onto your phone. Instead, it introduces multi-AP coordination. This means multiple access points can work together as a team, creating one big, distributed 16-stream network that can intelligently aim signals and serve clients way more effectively over a larger area.
So when you put all these pieces together, what does it mean for the big picture? Let's zoom out a bit and see how Wi-Fi 7 is going to shape the future of how we connect to, well, everything.
This is so important to understand. Wi-Fi 7 isn't trying to replace 5G. It's designed to be its perfect partner. With its super low latency and MLO-powered reliability, it's the ideal solution for high-performance indoor networks. There are even technologies in the works, like ATSS, designed to let our devices switch seamlessly between 5G and Wi-Fi 7, creating one unified, unstoppable connection. And believe it or not, the story doesn't even stop with Wi-Fi 7. The engineers are already working on the next standard, which is being called 802.11bn, or Ultra High Reliability. Its goal? To hit 5 nines of reliability. That's 99.999% uptime. That's the kind of performance we've only ever expected from plugged-in, carrier-grade networks, and they're aiming to bring it to Wi-Fi.
Whew, okay, we've covered a ton of ground here. So if you remember just one thing from this whole explainer, what should it be? Let's put it all together and get to the bottom line.
You know, this chart just lays it out so perfectly. Just look at the insane jump from Wi-Fi 6 to Wi-Fi 7. The max speed doesn't just inch up, it skyrockets from 9.6 to 46 gigs. The channel width literally doubles. The data packing efficiency gets a 20% boost. And the core technology shifts from OFDMA's focus on efficiency to MLO's revolutionary reliability. It is a massive upgrade on every single front.
And that leaves us with one final, very important thought. Wi-Fi 7 gives us this incredible toolbox full of power and potential. But to actually get that 46 gigabit per second performance, the rest of your network, your switches, your cabling, your internet connection, it all has to be able to keep up. The standard is here, the tools are on the table. The real question is your infrastructure ready for it?